Okay, kiddos. So, sorry about what happened with the notes. I thought everything recorded. I had the notes written in the on the smart, but I guess something happened. Don't know what. All right, so I'm gonna re-record example 3, 4, 5. Yeah. All right. So you're going to use the cast rule and the unit circle to determine the exact trig value. Okay, sorry about that. Okay, so use the cast rule and the unit circle to determine the exact trig value of each of the following. Remember, exact values are not decimals. Ever, 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 ever. Okay? So no decimals. They are fractions or radicals in simplest form always. Okay? All right. Now, there are some exceptions to it. We'll discuss that a little later on, okay? Okay, so if I've got sine 135, so take a look at your unit circle and see where sine 135 is going to fall. If it is on the unit circle, okay, which it should be, we have an exact value for it. Now, it's asking for sine, so you're going to use your cast rule. So I have that circled right here. Okay, so 135 degrees is going to be located in the second quadrant. That means sine is positive. And if we look at our unit circle, we get root 2 over 2. Okay, next, cos 210. Take a look at your unit circle, find cos 210. It's going to fall in quadrant number 3. That means cos is negative. That means our ratio is negative 1 over 2. 10, 135. So take a look at where 135, or sorry, 10, 315. So find 315 degrees. Remember how your coordinates are written as cos and sine. And 10, remember, is y over x. Or in our case, sine theta over cos theta. Okay? So sine of 315 degrees is negative root 2 over 2 divided by positive root 2 over 2, because cos is positive in quadrant number 4. That means that our tan value is negative 1. Sine negative 60. So this is a negative angle. So 0, 90, 180, 270. So we're going clockwise here. And tan 60 is going to fall right in there. And that means that if this is 60 degrees, okay, negative 60 degrees, if I go counterclockwise, right here, it's going to be equal to 300 degrees on the unit circle. So from there, we should be able to find that sine of 300 is going to be negative root 3 over 2. Okay, cos 225. So cos 225, let's find that on our unit circles, and we should see that it is negative root 2 over 2. Tan, negative 240, okay? So remember, it is we're going to be going clockwise. And we should find that it equals tan 120 degrees. So remember sine over cos. So it's going to be root 3 over 2 divided by, our cos is negative in this case, so it's negative 1 over 2, which means I've got root 3 over 2 times 2 over, I'll say negative 2 over negative 1. pardon me, positive 1. So now if I cancel these, my negative stays and my ratio is going to be negative root 3. Okay, sine 390. So if I have sine 390, that means that I am going one full rotation to 360 plus 30 degrees. Okay, so this is 390, which means that it is equal to sine 30 degrees. So in that case, my ratio is 1/2. Okay, so we've got H now. So we've got cos negative 570 degrees. If I draw this, okay, now I am going clockwise because I have a negative angle. So I'm going to go an entire rotation, 360 degrees, plus 210, which is going to land me roughly here. And cos negative 570 degrees is equal to cos negative 210 degrees, which falls on 150 degrees. Okay, so I'm going to find cos 150, which gives me negative root 3/2. All right. Use a calculator to 4 decimal places. The coordinates of the point on the unit circle that corresponds to a rotation of 148 degrees. Okay, this is one of those exceptions. So 148 degrees is not part of the special triangle angles. However, we can definitely find those coordinates. So remember, our coordinates are written as cos theta sine theta. Okay, so all we need to do is in our calculators, we're going to go cos 148 degrees and, oops, let me fix that. And sine 148 degrees, which when you put that in your calculator, so let's see how that's going to look. Oh, I don't have my calculator anymore. So just put in cos 148 and sine 148, and that should give us negative 0.8480 and 0.5299. Okay, that would be the coordinate. That's where you would find that angle. Okay, now the point T at negative 0.8829, 0.4695 lies on the unit circle. Determine the value of theta, where theta is made by the positive x-axis and the line passing through the point T. Okay. So if I put this, let's solve for theta r, because if we think about this, my angle is going to be, okay, I've got negative cos, positive sine, so that is going to have to be at somewhere in here, okay? So the coordinates of this point are at negative 0.8829 and 0.4695. All right, so we need to solve for theta r. So this is theta r right here. We need to solve for that. So all I do is in my calculator, because sine is positive, it's easier to work with. So I'm going to go sine -1, And in my calculator, I'm going to put 0.4695. Okay. And that gives me a reference angle of 28 degrees. So then all I need to do to find theta is go 180 minus 28, and theta is equal to 152 degrees. All right. The point P, 12 and -9, lies on the terminal arm of an angle theta in standard position. Determine the exact, determine the exact trig ratios for sine theta, cos theta, and tan theta. So I'm going to sketch this. Always sketch these out. So my cos is positive, my sine is negative. So where is that? That's going to be in quadrant number 4. So I'm going to draw my angle. And this gives me 12, and this is -9. What I need to know is, what is r? So x equals 12, y equals -9. We need to find r. Okay. So let's figure that out. So I'm going to go x squared plus y squared equals r squared. So 12 squared plus -9 squared equals r squared. Put that in your calculator. And I get 225. Take the square root. That gives me 15. Okay, so I get 15 for r. So now I can write my ratios. So sine theta is equal to -9 over 15. Cos theta is equal to 12 over 15. We need to reduce those. So that is going to give me -3 over 5. This is going to give me 4 over 5. And then I need tan theta is equal to -9 over 12, which gives me -3 over 4. Okay. Determine the exact values of sine, cosine, and tangent ratios for theta equals 120. So if theta is equal to 120, that falls on our unit circle. So for sine 120, that gives me √3 over 2. For cos 120, that gives me -1 over 2. And then for tan 120, it's going to be sine over cos, so √3 over 2 divided by -1 over 2, which gives me √3 over 2 times 2 over -1, which is going to give me -√3. So tan 120 is -√3. And I believe that is the end. I've got everything else. All right, so sorry about that. Here are the notes. Enjoy.